So now let's look at this example, which illustrate both greedy and also the idea of sweeping. This is a LeetCode problem called the non-overlapping intervals. So we are given a collection of intervals. So each of them is given by a starting point and end point. So this you can view them as on a number line. And we want to find the minimum number of intervals to remove so that the rest of the intervals are not overlapping with each other. So if two intervals are connected to each other just at the endpoint, that is fine. So for example, having 1, 2, and 2, 3 is fine. Having 2, 3, and 3, 4 is fine. But this 1, 3 will overlap with 1, 2, and 2, 3. So we have to remove some. And as it turns out, the optimal way is to remove this 1, 3, and then the rest of them are non-overlapping. So alternatively, we can remove 1, 2, and 2, 3. That will also make the remaining intervals not overlapping, but that's remove 2, so it's not optimal. So I strongly encourage you to try solve this problem yourself first before continue watching the video. I think you would learn more that way. So what do we do? So normally when there are intervals, it's the first thing one should try is sweeping. So essentially we sort the intervals and then process them one by one. An important question is what order should we use when we sort them? Well, we don't have to decide in the beginning, although usually we want to scan the interval from left to right, which actually turns out to be the case for this problem. But we don't actually have to decide that. So suppose we decide to, so suppose we decide to process from left to right. And then after we have seen one interval, now we're looking at the second interval. So what do we need to do? So yeah, that's another high-level suggestion for greedy, non-trivial greedy problem is just think about 2. Just think about if you only have 2 things you need to process, what would happen? So if they don't overlap, if we have already seen one interval, we remember that information, and now we're processing the second. If they don't overlap, then great. Then we can nothing need to be deleted, and we can keep going on. So if they don't overlap, then it would be nice if we can forget the first and then just keep track of the second, and then we will be looking at the third. Hopefully, the first will not interact with the third. So that this suggests that we want to sort by the starting point. Well, I guess sometimes we want to we may sort by ending point, and actually for this question, I'm not totally sure whether sorting by endpoint would also work. I expect if we sort by endpoint, we need to process from the right to left, but I'm not totally confident about that point. But sorting by starting point would work, because if they don't overlap, then that means the first one has to be totally to the left of the second one. And then it will have no chance to interact with the third one, because the third one will start even later than the second one, or at least no earlier than the second one. So it shouldn't, the first one should not interact with anyone else. We can forget about the first, just need to remember the second. Now, if they do overlap, then we have to remove one of them. Now, which one should we remove? So here, this is where the key greedy idea come in. We want to remove one so that we minimize future conflict with other interval. So we should remove the ones that end later. So if we have 2 intervals, if we have, I think I have an example here. If we have a 1, 4, and 2, 3, we will remove 1, 4. If we have 1, 3, and 2, 4, we will remove 2, 4. So just keep track, because we need to remove one anyway. So we might as well remove the one that could cause could cause us most problem in the future. So we remove the one whose endpoint is the larger. So So this seems to actually work. This given algorithm to process every interval. And all we need to do is to remember the current interval we keep track of. And in fact, if you read this, the things we check, you realize actually the left point never matters, because once we sort the interval from left to right, the left point doesn't matter. When we check whether this interval overlap, we care about is the right point of the current interval, the end point of the current interval. So all we need to remember is actually just the end point. So we just need to remember one integer, which is among all the intervals we kept, we didn't delete, what is the last one's ending point. So that decides everything. So that's my code. So this is the main part. It just doesn't include the comparator for this sorting here. So after sorting, I initialize this right point. So this R is the state I'm maintaining while I'm scanning through the interval. It's the ending point for the first interval. And it's because of this, I need to get this right ending point of the first interval. I need to check this degenerate case where the interval is the array is empty. Then I don't need to delete anything. Otherwise, I get index out of bound on this access. So then I start by looking at the second. So this answer stores the number of interval I'm going to delete, starting from the second. And this part check whether there is overlap. So if R is greater than x0, so then there is an overlap. So R is the endpoint of the previous interval, x0 is the starting point of the current interval. So when there are overlap, then answer need to increment by 1 because we need to delete one interval. And then our new right point is the minimum of the current one and the x1, the current one we remember, and the current interval, the right ending point. So whichever is smaller, we keep track of that. So if they don't overlap, then we can forget the first interval and then keep track of the right point of the second one. So R equals x1. And so that's it for this, except for this comparator. So in the discussion, we said we're going to sort by the starting point. What if two intervals have the same starting point? So what order should we use then? So on this slide, I given two comparators. One of them compare the endpoint, but prefer the one that start earlier, and the other one prefer the one that end earlier, the first one. The other one prefer the one end later. So, but the question is which of the above comparators is correct, and why? So I want you to think about it, because ordering is the key to this kind of a sweeping problem. And in fact, on the slide and in the video, I'm not going to give an answer. So you should think first, and then you can try on LeetCode to find out the answer. Yeah, so in summary, for this problem, we sort the intervals primarily by starting point, and then we will process them based on the order we are sorting, essentially from left to right. And when two interval overlap, we will remove the one whose ending point is to the right. So this is making a locally optimal decision. This is a standard greedy approach, and it turns out to be correct, because that's the only interaction these two intervals could have with future ones. So we only making local optimal decision turns out to be fine. So that's it for this problem, and we have one more for this topic.